Scheduling Operations, Chapter 12 lecture. I just want to point out aggregate planning versus scheduling. Again, aggregate planning is more of a how many total units are we going to produce in this area and how many total in this area. It does not necessarily break it down. Scheduling is much more of we are going to make 50 red pens and 500 blue pens instead of just 1,000 pens. That 1,000 pens might be aggregate planning. Okay. Scheduling consists of short-term decisions that are constrained by previous decisions regarding facilities and aggregate planning. So let's say that you want to make this product and you need to purchase some parts that are going to take 1 month to order and get it into your facility, so a month. And so let's say you order those parts and 2 weeks go by and then you decide, you know what, I really didn't want to make those parts yet. I wanted to do those later. I would have rather ran these other parts, but because I've already ordered these and they're already coming in, I'm kind of constrained. I'm going to have to probably run those parts anyway, even though it may not be the optimal solution for my facility. Dating decisions are kind of like that. You make the decision to start dating and then you start to make commitments, and again, the future decisions are based on what you decided in the past. Do I go out with this person? If I go out with this person, or do I go out with this person again? And sometimes as you march along that path, it becomes your future decisions obviously are based on your past ones. If you decide to get married, it was partly because you made the past decision to actually start going out with this person. So efficiencies. We talk about high efficiency in terms of making sure your machines are kept busy and things are not waiting. So one of the things that the questions I pose is, how might high efficiency conflict with low inventories? Well, if you have problems with change over time, how much it changed, how long it takes to change from one product to the next, then if you're constrained by that, then you are going to try to run big batches of stuff, because if it takes you 4 hours to change over, when you start to produce something, you want to produce it for a while because you want to produce it for 12, 16 hours before you change over, because it takes such a long time. And so if you're trying to maintain high efficiency, keeping your machine producing parts, then you may end up generating more inventory. So it's a conflict. Marketing wants to make sure every customer's order gets delivered as promised, and especially the most important ones. Who might be the most important customers? First answer is the one that you have the biggest amount of business. The largest percentage of your business is tied to that particular customer. That's one. Another one that you may be very lean favorably towards is the ones that they may have lower volume, but they have a lot of profit to them. So you might, defer to them in many cases. Or the promise of more business, you might defer to those customers. Number 4, how might operations accomplish this? And this is, operations will try to get as many orders completed as possible regardless of their priority or monetary impact. So if you had a number of assignments that were due in the coming weeks, next 4 weeks, we'll say, then if you were trying to get as many orders completed or as many homework assignments done as possible, you would focus on the ones that were the easiest and the fastest to get done, even if they were not the most pressing. So they would focus, again, the operations would focus on the ones that you can get done with the fastest and you have the material for, and so that's what they would do, even if it wasn't what was most pressing. Scheduling batches. One of the characteristics of a batch operation is that jobs or customers spend most of their time waiting in line to be processed. And we've talked about this, and there's an illustration sometimes I do in class with paper footballs. But why does this happen? Well, and I've alluded to it in prior videos, is that batches, you may run, again, 50 pieces, 100 pieces, 5,000 pieces. It all depends on, you know, how fast you can produce them. Let's just say 100 pieces. Well, so you get 100 pieces, and when you're done with those 100 pieces, you send them to the next operation. So within that, what ends up happening is I start working on the first one, and the other 99 are, yes, waiting to be processed. I work on the second one, and the first one is waiting, as well as the other 98 of them, etc. And so that's what happens. And it makes it even worse is that sometimes as they go to the next operation, they're not ready for them because you're using a push system, and so they sit there waiting to even be started. Gantt charting, we've talked about that in the past. Again, I would imagine that you'll do this at some point in your career, regardless of your major. This Gantt chart is really focusing on how work is processed, and you'll see here work center job 1 is it spends 2 hours in A, 3 hours with machine B, 4 hours with machine C. So they schedule it this way, and then this machine is tied up, and so what ends up happening is operation or job number 5, part number set number 5, it says, oh, we'll run this one for 5 hours, and then we'll drop down, and 4 is being run, so we have to wait. So we have to wait for about an hour. Then we can start 5 here. And so it's all this coordination. Now, in reality, there is software that does this for you, so you don't really have to deal with it, except to understand that there's always constraints trying to make everything work as smoothly as possible. I would want to point out that when it talks about job waiting, is time waiting to be processed. So this one here, when it gets done at the 7th hour, that it is waiting for an hour to start because it's waiting for job number 4 to be finished. Delivery time is when done, or minus when it could be started. Okay. So when it's done versus when it could be started. Okay. Job interference. The waiting time of a job depends on the job interference encountered. This was job interference. Something was in its way. Or this was in its way. It could have started right then, but there was this other job waiting to be already in process. So job interference is, again, because you just may not have enough equipment, you may not have enough employees, you may have not enough parts because something's running behind. But job interference is, you could start the job, but you can't for some reason. Finite capacity scheduling, FCS, and it assumes that a job can be split into 2 or more parts if this will facilitate scheduling. So let's say that you want to make 200 parts. Well, the customer may be really eager to get these parts for whatever reason. Their volumes are low, their inventory is low. So you may say, well, you know what, there's 200 parts we're going to send you. We'll go ahead and process just 50 right away, and then we'll follow up with the other 150. And what happens is, with processing just 50, there's a lot less wait time because you produce 50 instead of waiting 200 for each batch to move on to the next operation. So it's beneficial because it gets the material through your facility much faster and hopefully to your customer. Bottlenecks. A bottleneck resource will constrain the capacity of the entire shop, and an hour added to a bottleneck will add an hour of capacity to the entire plant. Okay, so here's a couple of whys here. Let's say you have this picture here. You have machine A, which produces 100 pieces per hour, machine B 200 pieces an hour, machine 3 150 pieces an hour. And all three of these products go to the machine D, which is produces 50 pieces an hour. Now, the problem is that after the first hour, this machine has sent over 100 pieces, but the machine can only produce 50 an hour, so after an hour, 50 pieces have been processed, and 50 of these pieces are just sitting here. It's even worse with machine B, is that it can process 50 an hour, so after the first hour, 150 of these will be waiting. And here, 100 pieces will be waiting. So, if I can somehow do something to make this machine produce more, work longer hours, maybe add a secondary machine that is not as effective or efficient, but it still helps you to push stuff through the facility faster. So it says here, a bottleneck resource will constrain the capacity of the entire shop, and an hour added to a bottleneck will add an hour capacity to the entire plant. Because if I can add an extra hour of work here, let's say I work an extra hour of overtime, I just had 50 more pieces that I was sending out the door that day. Whereas if I work an hour overtime on this one, I get no additional benefit. All that happens is I have more stuff sitting waiting for this machine to process. Okay, there's that question. An additional hour capacity added to a non-bottleneck work center will not help the schedule at all, since excess capacity exists there. How can this be? That's this example. I don't work an extra hour here, but I work an extra hour here. All I've done is send an extra piece, 100 pieces over here, and it's still not getting through any faster because this is the bottleneck. All right, we're going to stop in this segment.